Hello, everyone. This is Jermaine from Alibaba Cloud Singapore. Welcome back to the ApsaraChat mini series episode 2. Let me give you a short recap of what we did last month, especially for those who did not join us. So we did an overview of AI on Alibaba Cloud and a demo on spam sorting. And today, we will once again give a brief overview and demo on predicting prices. And then without further ado, let's welcome Jeremy. Can we have the sound, please?
Learning model to sort spam. This time we'll be looking at... All right, hello and welcome. So welcome back to the second ApsaraChat session. I'm one of your hosts, Jeremy Peterson. Today we'll be taking a look at Alibaba Cloud's machine learning platform for AI, or PAI. Actually, this is what we looked at in the first ApsaraChat session as well. Last time we looked at how you can use PAI DSW, our Jupyter Notebook service, to train a machine learning model to sort spam. This time we'll be looking at something a little bit different. We'll be looking at how you can use our Visual Studio interface, our GUI tool, to build a linear regression model that can predict the price of houses. So without wasting any more time, let's get right into it. All right, so before we get into the hands-on part here, let's talk a little bit about the machine learning platform for AI, or as we like to call it, PAI. This is basically Alibaba's tool for training, testing, and deploying machine learning models. You'll do most of your machine learning related tasks inside of PAI. And I want to look at PAI from three perspectives. We'll look at AI use cases within Alibaba Group and have an overview of our other AI products and services. Then we'll look at how you can use PAI as a one-stop AI development platform. And then finally, we'll look at some solutions and best practices. I'll link to some hands-on labs you can try, and then we'll have our demo. Whoops, I skipped a slide. Let me go back. So the first AI scenario inside Alibaba Group, and probably one of our biggest AI use cases, is what we call PAI. This is actually the image search tool that we use in Tmall and Taobao. So if you're using the mobile Tmall or Taobao app, there's actually a little camera next to the search bar. You can click on that and take a picture of an item, and we will find similar items on Tmall or Taobao. That way you don't have to do keyword search. You can actually find your items by taking a picture of them. And this works even in noisy environments. So like you can see in the center here, we have a woman walking down a busy street. There's a lot of, issues with this image. The lighting isn't 100% perfect. You can only see the bag from one angle. It might not be the same angle that the bag is posed on our site. There's other obstructions like clothing and hair, other people in the scene in the distance. So even despite these issues, the PAI system can actually determine on its own that what you're interested in is the bag, which is at the center of the frame, and it can then isolate similar items from the Tmall or Taobao retail database and display those results to you. So it's a super awesome tool for retail companies. And actually, you don't even need to use Alibaba PAI to use this anymore. We've actually published the PAI API, this image search API, as a separate component that you can integrate into your own apps. So it's a pre-built AI application. We also use AI internally for online recommendation. In fact, if you turn on the PAI service under your alibabacloud.com account, there are some examples in there, some experimental examples you can play with of pre-built models. And we have a model for online recommendation that you can just play with on your own. So that's a super cool way to get some experience with PAI by actually building a recommender system. AI scenarios, face-based payment is something else we use heavily within Alibaba Group. So we now have face-based payment vending machines around the campus. In fact, as I record this, just up the hall from me, we have a machine where you can scan your face to unlock the door, pull out the items you're interested in. A camera in the machine identifies which items have been taken out, matches them to your face, and then charges your Alipay account automatically. So we do a lot of facial recognition stuff in Ali Group, and in fact there are pre-trained facial recognition models built into our PAI product as a result of that. So we're a very heavy user of data. Alibaba Cloud, in particular, being the support engine for the rest of Alibaba Group, processes and analyzes a lot of data. So Alibaba Group is very much a business or a data-driven business entity. We rely on massive amounts of data from our applications and about our customers to make better predictions, to decide our future direction, to improve our products, to do all of that. So we're heavy users of machine learning and AI internally. And we've built that into our products. So when you use PAI, there's a lot of built-in components for different machine learning, filtering, and data processing tasks based on our own internal experience of what we've needed to build systems like PyLitao image search and the Tmall recommender system. So if we look at PAI from a high level, under the hood, the data that PAI works with is stored in a system like eMapReduce, Flink, or Max Compute. Max Compute is the most popular choice. This is our offline big data processing engine. You can then run common machine learning frameworks on top of that, including PyTorch, TensorFlow, Caffe, and also some proprietary modeling tools that are built into PAI itself. PAI actually is made up of several different components. PAI Auto Learning can help you to automatically tune and test new models to optimize them better. PAI VIP can help you do video feature extraction, text recognition, face recognition, and labeling. PAI Studio, which you can see on the left of my slide here, in the middle, PAI Studio allows you to use a drag and drop GUI to build models. That's what I'll be showing you today. And PyDSW allows you to write Python code in a Jupyter notebook so you can run custom models or use open source tools like PyTorch. In fact, if you took part in the first ApsaraChat that we did a little earlier last month, if you took part in that first ApsaraChat, we actually built a spam sorting model using PyDSW. This time we'll be using PAI Studio. And then, of course, in addition to those built-in tools for building your own models, you can buy or use models from our AI marketplace. You can actually buy pre-built models from the AI marketplace and deploy them directly. Or, if you take a look at the top of the slide here, you can deploy models using PyEAS, our Elastic Algorithm Service. So you can build your own custom model and then deploy it directly as a RESTful API through Alibaba Cloud's API Gateway. In fact, if you do that, you can even take your published model and sell it on the AI marketplace. So if you have a new model nobody has, you can sell that model on the marketplace for money. PyDSW, again, this is what we played with in our first ApsaraChat session. This lets you enjoy a variety of open source machine learning frameworks in a traditional Jupyter notebook environment on the cloud where everything's provisioned for you. And you only pay for that environment when it's running. So this is a good cost saver for testing and development. PyStudio, which is what we'll look at today, is a GUI-based tool for AI and machine learning. This allows you to automatically test and train models. It has an AutoML feature that will automatically adjust model parameters for you to get the best fit. It has built-in components for data processing, sorting, filtering, feature extraction, visualization, model evaluation, and model training so that you don't have to write your own code. And all of this is accessible from a nice GUI interface. Then there's PyEAS. Once you've produced a model in either our notebook interface or in PyStudio, then you can go to PyEAS to deploy that model out as an API. So you can make that model available to users on the internet or to internal users via a private endpoint as a RESTful API interface. So you can take your model and make it available directly as an interface that other people can integrate into their applications. And of course, with EAS, you can see a bunch of useful statistics about how well your model's running, how many API calls are coming in, all of that from the built-in monitoring dashboard, which is great because then you can see in real time what the performance of your model is, how long inferences are taking, how many calls you're getting, and this way you can have some advanced warning if you need to make some kind of an adjustment. And of course, PAI has really good performance compared to a lot of open source solutions. There's a performance enhancement of up to 7 times. It really depends what model you're running, what task, but the performance is really good. And for large data sets, you get an almost linear speed up thanks to our GPU resource optimization engine. So if you're training a GPU-based model, those models scale really, really well across multiple GPUs on Alibaba Cloud, thanks to the Apsara AI platform, which we use for advanced GPU scheduling. In terms of solutions and best practices, The reason we built Pi is to deal with this problem here. So this is from a Scully paper from Google at NIPS in 2015. So if you look at this AI bucket theory image from his paper, you'll notice that writing machine learning code is just this tiny, tiny component in the middle. Everything else around it, from data collection to data verification, is in fact where you spend most of your time. So Pi is designed to help you eliminate or automate configuration, collection, feature extraction, so that you can spend more time focusing on your machine learning model, which is the heart of your machine learning system, because traditionally you end up spending a lot of time on these other tasks instead. Pi integrates well with our other products, so you can use it in any typical machine learning scenario that you have. So you can combine Pi with Max Compute and DataWorks. You can ingest data into Max Compute via the DataWorks data integration tool. You can then take that data, push it out to Pi, train machine learning models on it, and publish those models as APIs using the Pi EAS service. So you can basically take any data you've already got, pre-process it in batches on Max Compute, feed it to Pi, and then export the final product as a trained model that you can call via a friendly web API. For instance, if you wanted to build a recommendation engine, all you would have to do is open up Pi Studio, choose the recommendation engine model template, play around with it, make sure all the parameters are set the way you want, click on Run to train the model, and then use AutoML to adjust the parameters, and then publish the final model, and then you've got a recommender system ready to go. There's also built-in computer vision capabilities, so that's Pi VIP, which I talked about earlier. It can do text recognition, text detection, image segmentation, classification, object detection, and image segmentation. We have built-in models for all of that that are pre-trained, so you can get those models working on new data sets with very little effort because we have pre-trained them on our private data sets. And if you want to try out Pi yourself, but you don't have an AlibabaCloud.com account, or you want something that's got a little bit more hand-holding, so if you're new to this and you want some help setting up Pi, these labx.io courses here are a good fit. So labx.io is our hands-on lab partner. You can sign up for an account with them, buy some lab credits, and then you can use those lab credits to do one of these two Pi labs here. They'll provide you with a lab instruction manual and a temporary Alibaba Cloud account, and then you can go ahead and try that, try the Pi environment hands-on in a guided fashion. Okay, so let's try and train a system to predict house prices. That will be our demo for today. Let's try to figure out house prices from some related data like house square footage, number of rooms, number of floors, size of basement, etc. Let's do it. Alrighty, so let's go ahead and build something. So I'm here in the Alibaba Cloud console. What I'm going to do now is set up a Pi machine learning project, and we're going to train a model to predict house prices. So what I'll be doing is I'll be starting from this data set here. This is house sales in King County, USA. If you're wondering where that is, that's the area around the city of Seattle in Washington State. So this is house prices in Seattle, essentially. And we've got this data set here, which if you look at the Kaggle page, we've got an ID number for each house, for each property, the date that it was listed, its current price, number of bedrooms, number of bathrooms, livable square footage, total square footage, so that includes the yard, and then we've got things like the number of floors, whether or not it is a waterfront property, whether or not it has a view, and then there's a few other things in here as well. There's actually about 20 different columns. You can see there's also stuff like grade, basement square footage, the year it was built and renovated, zip code, location, and then there's these redundant square foot, lot, and living fields, which we can mostly ignore. And there's 300 plus unique different values in here for the date. There's actually many more properties than that. There's several thousand. So what we're going to do is download that data set and import it into Pi. Before I can do that, I have to go back to the Alibaba Cloud console, and I need to do actually two things. Before I open up our machine learning platform for AI, which we often call Pi, I first need to go over to DataWorks and set up a new DataWorks project. So I'm going to do that first. So I can choose any region that I've activated. I've activated US Silicon Valley, Shanghai, and Singapore. I think for this project, I'm going to use Singapore, and I need to create a new DataWorks workspace. So I'll do that now. I'll click on Create Workspace, and I need to give it a name. House Pricing Demo seems fine. I'll use that as the workspace name and the display name. You can choose the basic mode for your DataWorks project. In basic mode, There's only one max compute project inside DataWorks, so all your tables live in one simple space. There's no separate dev and production environments. It's all just together. For doing a simple demo in Pi, that's totally fine. So I'll choose basic mode here. Next, I need to choose what compute engine I'm going to use. I need to choose max compute, and I want to tie Pi into this. So Pi will have access to all the max compute tables that are part of my DataWorks workspace. So I'll click on next. We need to give our max compute project a name. House prices max P seems fine. Okay, click on create workspace, and that will go ahead and create this for us. So I just need to wait for that to happen. So we wait a couple of minutes here. Okay, the workspace is created. So now if I go back into the DataWorks console, into my workspace list for Singapore, I see this house pricing demo showing up here. That's actually the last thing I need to do in the DataWorks console. From this point on, we can do everything via the Pi console. So machine learning platform for AI is over here. Okay, I'll open that in a new tab. And there's several different ways to use Pi. One of them is the DSW, or Data Science Workshop Notebook. This is essentially a Python-style Jupyter notebook. We're not going to use that. Instead, we're going to use what we call Studio Modeling Visualization. And this is really cool because what Studio Modeling Visualization does is it gives you a low-code or no-code workflow where you can process data, tweak your machine learning algorithms. You can look at training results to gauge accuracy. You can do all of that using a drag and drop GUI interface. So again, I need to choose Singapore because that's where my DataWorks project is. And sure enough, I can see my DataWorks project in here, house pricing demo, and I can click on machine learning to open up that Pi GUI interface. And the first thing I need to do is create a new experiment. The experiment is going to hold all of the blocks or elements that I string together to test and train my system. So I'll call it house price predictor. I think that's under 32 characters. House price prediction with linear regression. Oops, that's too long. I'll just call it house price prediction. And then I'll save it in the My Experiments folder. And that creates this nice new blank dashboard here where I can start dragging and dropping components. Of course, at this point, I don't have any data. So let's go ahead and get some data. All right, so I'll switch over to this Kaggle tab, and there's a download button at the top. I've already logged in, so I've already logged into Kaggle. If you have not used it before, you'll want to go ahead and make an account first, and then log in, and then find this house sale price prediction data set. I'm going to just click download. That will push this into my downloads folder, and then I should be able to open this up in Numbers. So let me do that. Actually, I did that before. Let me delete that. All right, so if I go to downloads, I should be able to see this archive.zip folder. And sure enough, in there, let's see, we should have kchousedata.csv. This is our housing data. Let's take a look at that in an editor. You can use Excel. I'm on a Mac, so I'll use Numbers. But we just want to get a feel for what the data looks like and how many columns there are. So it looks like we have 21 columns: ID, date, price, bedroom, bathroom, square foot living, square foot lot, floors, waterfront, view, condition, grade, square foot above, square foot basement, year built, year renovated, zip code, latitude, longitude, square feet living, and square foot lot. And these look to me like they are, they appear to be different from the ones over here. So I'm not sure what the difference is between those. We won't worry about that too much. One important thing is that there don't appear to be any blanks, and it looks like most of the numbers are, all the fields are numeric. So that's good, except for the date. All the other fields are numeric, so we can put these into our database as integers or as floating point values, depending. So now I need to edit the table a little bit. Let's hide this title field. I want to remove that. Hide table title. To make Pi happy, I will also need to delete this header row, and then we'll go ahead and export this. Whoops, not Excel. I want CSV. We'll go ahead and export to CSV, and we'll save this in downloads as KC House Data Prep, so I know it's pre-prepared and ready to go. So now that I've got this in CSV form without a title row, I'm ready to import it into Pi. So let's go ahead and do that. So I need to go over to data here. And I can use some of the public tables that are built into PAI if I want, or if I have my own data like we have here, I can go to create table and make a brand new table to hold my own data. And there's two ways to do that. I can enter a table name and life cycle info and a table schema through the GUI, through the visualization mode, or I can enter SQL commands. So I can use a DDL statement. I'm going to do that because I already have one written down. So I've got it sitting here in text editor. I've actually already prepared all 21 rows. I've chosen their data types already. I'll just copy this all in, and that will save me a lot of typing. So we'll go back over here and paste that in. This will create a table called housing data with all of these fields, which are the same fields that are in my Excel sheet. Then I click next, that creates the table. Now I need to upload my data. And when I do that, I can set the row delimiter and column delimiter. So even if the values in my table are separated some other way, maybe I didn't use commas, maybe I used equal signs or colons or semicolons, no matter what the separator is, I can choose it here. I can choose an appropriate separator that matches my input data so that I can make sure it imports successfully. So I'll go ahead and select File here, and we'll choose KC House Data Prep. And you can see, sure enough, using this row delimiter and this column delimiter, it looks like things work. This preview shows what I expect. All the fields are nicely separated. And then I click OK. That should go ahead and import the data. And I'll hide this download tab too while I'm at it. All right, so that's taking a moment to import the 2 megabytes or so of original data into my Max Compute project. So actually the data is being stored in here. It's being stored in a Max Compute project in DataWorks, and PAI will read and write to that Max Compute project. So PAI actually depends on Alibaba Cloud Max Compute behind the scenes. And sure enough, here's my table, and I can actually drag that onto my dashboard now, onto my experiment, as a component. And then I can start working with that data. So let's go look at the components list. There's a whole section of components here for things like data preprocessing, standardization, normalization, dealing with missing data, converting data types. I can do all of that before I actually start doing machine learning. So I need to do, firstly, I need to normalize my data. So let me add normalization as a step here. I just drag an arrow between these two blocks to indicate the connection between them. Normalization can take more than one input. But in my case, I only need to input one table to my normalizer, so I'll just use this node on the left to connect my data source to my normalization block. I can then click on the normalization block, and that will let me set the configuration for this block, so I can choose which columns in my origin dataset I want to normalize. If you're totally new to machine learning, I'll just say this. Some linear models, like linear regression, work better if you scale all of your input data source so that it's all within the same numerical range. So you might want to scale all of your different input columns so that they fall in the range, say, from 0 to 1. That scaling can help your linear regression model or your other linear model to converge on a solution faster. So that's what I'm going to do. I'm going to choose the columns here that I want to use as inputs to my model. The things that I use to predict the price, I'll choose them here, and then the normalizer will do its magic on them to compress them down into a normalized range. So I'm going to ignore the ID, which has no predictive value, and also the zip code. The zip code might actually have predictive value, but I don't think that the zip code, the scale of the zip code actually has anything to do with the price of the house. I think it will be confusing, so I'm going to leave that out of the data set. This demo is way too short to get into the hairy details of why you would choose to exclude certain inputs when you're building a model. There's certain things in your data set you might want to clean or adjust or ignore. Let's just leave it at this. The zip code, although it might indicate how much a house is worth, I don't have a good, accurate way to feed that into my linear regression model right now, so I'm going to ignore it the same way I ignore the ID. I'm ignoring the ID for the very obvious reason that the ID is just a delimiter that makes each row in the database unique. It has nothing to do with the price of each house, so it has no predictive value, so I can safely ignore it. The rest of my fields, I'm going to keep them and normalize them, except for price. I will not touch price because that's going to be the output of my model. It's not going to be an input to my model. It will be an output. All these other things, living space, lot size, number of bathrooms, number of bedrooms, whether or not it has a waterfront view, the condition of the house, 0 to 10, the year it was built and renovated, its physical location. I think these are all likely to have some predictive value on the price of the properties. So I'm going to include all of them as inputs, and I'm going to normalize all of them. So I'll click OK to select all these other columns except price. And then I need to split my data set up. So the next thing I need to do is split my data into a test and a training set. If you're new to machine learning, you might not know why we're doing that. The reason we do this is to make sure that the model we build actually works. When you train a machine learning model, it's possible to have a problem called overfitting. This means that the model actually fits your input data too well, and as a result, it will do a bad job on real-world data later. So splitting your data into a test set and a training set can help prevent overfitting because it allows you to see how the model will work on data it's never seen before. So you'll give the model, say, 80% of the original data that you have, and you'll save the other 20% for testing later on to gauge the accuracy of the model. So that data that you never used to train the model will serve as your sanity check to make sure that the model's really working. If you give 100% of your data to the model as input, then you might end up with a model that's really, really good at predicting outputs for that whole input, but then fails on data it's not seen before. So you hold some data to the side as part of what we call the test set, and then you use that test set later to make sure your model is actually working. You can choose the split ratio for the split node. Here we've chosen 0.8. That means that this node on the left here, 80% of the data will come out here, and the other 20% will come out here, and we can use that for testing. And if you think your nodes are getting messy, you can actually adjust them using this auto adjust feature, which will nicely line them up for you. Okay, so after we split, now we can start training our model. So I need to go find a model. So let's close this data preprocessing and statistical analysis stuff. Machine learning, we'll go down to regression and we'll choose linear regression. Great. I will feed 80% of my data into that, and then I'll grab a prediction node. This is going to tell me how good a job my linear regression did. I'll feed into that prediction node my test data and the output of my linear regression model. Perfect. And then I want to see how well that all worked. So if I go back to statistical analysis, I think, actually no, let me see, the regression model evaluation, that's what I want. So I'll drag that under prediction, feed prediction into that. Now I've got a complete workflow. So let's go back and look at it, and I'll re-explain what everything does. So housing data is our original data set. Normalization is going to take the feature vectors, the columns in that housing data data set, and normalize them, meaning it will compress each of those input features down into a fixed range, so that no input feature has more of an impact on the training of the model than any other. Then we split the data into test and training sets. We'll feed the training set into our linear regression model. We'll feed the test set into a predictor. We'll use the predictor to compare the output of the trained model to the expected output on the test set, which we fed into the predictor here. And then we'll feed the output of the prediction out to this regression evaluator here, which will tell us how well the model worked. That should be everything we need to do to build a functioning model. So let's go ahead and run this and see what happens. So all I need to do is click on run and then wait for this thing to finish. And you'll notice I didn't have to write any code. I don't even really need to know how linear regression works. I just need to know what a typical input to linear regression should look like. Oh, actually I didn't finish. We're not ready to run. So in addition to choosing a split ratio here, I also need to go down here and I need to choose which columns are my inputs, which is everything except price. I'll click OK. And which column is my label column, which is the output, the thing I'm trying to predict, which is price. Same thing for prediction. I need to know what my features are and what my reserved output column is. So reserved output column, let's unselect all this stuff. Reserved output is price, and the input column is everything except price and ID and zip code. And we'll also ignore date. Date doesn't really have a lot of value for us. Okay, so I've got my 17 feature columns and my output column. I'm going to compare that output to the predicted price here in the prediction model Same thing when I get to the regression evaluator, I need to know what I was trying to predict, which is price, and I'll compare that to prediction score from the prediction node. That should be all I need to do. So we can go ahead and try running this now. So I'll just click on run. Once I do that, let's auto adjust the size of this so it all fits on the screen. Once I do that, that will start running through the process of normalizing my data, splitting it into test and training sets, running linear regression on it to train the linear regression model, evaluating that model to see how good its performance is, and then running a regression evaluator. So let's go ahead and do that and see what happens. Right, so after waiting a bit, you can see there's now a green check mark next to each of these nodes. That means that the workflow has successfully run. So all these steps have succeeded. I can click on any one of them and look at the run log to get more details about what happened and how it happened. Or I can take a look at, say, the output data from the model. So I can say view output port 2, for instance, and that will tell me if there's any output data from this, this port over here. Obviously there isn't because I didn't hook it up to anything. I can even export the model as a PMML file if I want to. So I can do all kinds of cool stuff. If I view the analytics, that will give me information about any data that the node contains. In this case, it's a model node, so it doesn't have any. What's more interesting to look at is these two nodes here. If I look at prediction, I can see the results of the prediction step. So for instance, you can see here, this house was $1,225,000. That's the original actual price. And the model predicted that it would cost $1,465,000. Here the price was $257,000, and the model predicted $228,000. So it's not too bad. Of course, going through these one at a time is going to be a lot of work. So instead, we have the evaluator, the regression model evaluation node here that we can look at. If I look at the analytics for that node, that will give me much more valuable measurements like the mean absolute error, the mean squared error, the R and R squared values, the root mean squared error, and so on. And that will give me a general idea of how the model did overall. In particular, R squared here, that gives me an idea of how much of the variance in the input can be, or excuse me, how much of the variance in the price can be predicted by the model. An R squared of 0.7 is okay. The R squared value can vary between 0 and 1. 1 would be a perfect match, meaning that the model is a perfect fit to the data. If that happens in real life, probably something is wrong. 70 or 80% is pretty good for linear regression. On a simpler data set or with more cleaning and pre-processing, you might be able to get up to 90%. 70% is already okay. That's a pretty good fit. But if we look at the mean squared error or the mean absolute error, we can see that the model is making very, very wildly wrong predictions for a couple of outliers. So in particular for the mean squared error, the mean squared error penalizes you for being wrong it penalizes you more for being wrong in cases where the error value is larger because it squares the errors. So in cases where you've made a prediction that's very far off, even if it's only 1 or 2 cases, you'll end up with a high mean squared error. So it looks like there's a couple of houses in the data set where we make a prediction that's wrong by maybe an order of magnitude. So there are a couple of data inputs in the data set where the prediction in terms of square footage and waterfront and quality, etc., result in us predicting a price that's either much lower or much higher than the actual price. But in general, it looks like we're doing okay based on R squared. The mean absolute error here says we're averaging a wrongness of about $120,000. So that's the average difference between what we predicted and the price of the house. But if we look at the prediction mean and the Y mean, which means the mean value we predict and the mean cost of each house in the data set, we see that they're pretty close. So it looks like there's just a couple of outliers where the model does badly, and we could go back and look at what might be causing that by examining the data in a visualization tool, and then we'd be able to make adjustments to the model or to the inputs that would result in a more accurate model. But of course, tuning the model is out of the scope of this talk. In fact, tuning the model is really the hardest step. So if you're planning to get into data science or machine learning professionally, if you're not already doing that, you'll quickly learn that understanding the algorithms and what they do and how to train them is not the hard part. The hard part is data cleaning, pre-processing, and feature selection. We didn't do any feature selection. We just included pretty much everything from the input as a feature. That got us up to an R squared of 0.7. We could probably do better if we did some feature engineering and added or deleted some of those input features that we used. Okay, that's it. We now have a complete trained model. So what could we do from this point? Well, one thing we could do is we could actually deploy this model. So there's something here called online model service. This actually allows us to deploy our model through Alibaba API Gateway such that you can access it just like any RESTful API on the internet. So you get yourself a signing key, and then you can call the API endpoint, provide some information about a house like square footage and current size of the yard, and whether or not it has a view and all of that. And then the model will send you back in REST API form a JSON document containing the price of the house. You can actually publish models for online use through the online model service, or you can actually use your models inside a DataWorks offline workflow. So if you have a regularly scheduled workflow that runs every week or every day, you can have this model make predictions as part of that DataWorks workflow and then save those predictions into a max compute table inside your DataWorks workspace. So you can do both of those things: publish an online living model that you can call anytime from the internet, or use the model internally in a DataWorks project. And that's automatic. You don't need to write any code for that. You just click on deploy, choose the deployment type, fill in some values, and then you're good to go. So for instance, if I clicked on online model service, it would say, okay, what model do you want to deploy? And then it would take me over to this model service page where I'd set up the parameters for serving up the model. I'm actually not going to fill that in, but you could do that. All right, and that's it for the demo. I hope that was useful, and I hope you learned a lot about PAI and about machine learning.
Okay, I will be taking over from here. Can everyone hear me? Okay, hope everyone can hear me. It looks like my mic is going.
Yep, can hear you loud and clear.
Cool, cool. And you can see me?
Yes, we can all see.
Good, cool, cool. So thanks, Jeremy, for giving us another demo on our PAI, Alibaba's machine learning platform. It's great to see just another use of it and jumping in the console so we can see how that stuff actually works through. I'm here to provide some industry examples of where machine learning can be used, and also talk a little bit about the certification course offerings that we have offered by the Alibaba Cloud Academy. So I'm as a personal fan of the development of the AI industry and what tech companies all around the world are doing with AI, I'd like to just let you guys know what some things that are happening. You're probably familiar with some of these, but it's going to help you brainstorm in thinking what you can do with Alibaba Cloud's PAI when you jump into a project. Help you brainstorm what you want to do, and help you sort of piggyback off other companies or other projects in the industry that that will help you put your ideas together. There's virtually no major industry, modern major industry that is performing objective functions using data trained models. And that often falls into the categories of deep learning, machine learning that has not been affected by AI. So any industry that uses computation, anyone that touches computers is most likely working with machine learning models and AI models to improve what they do. That's especially true in the past few years as hardware and software has improved to the point where we can run much more complicated models, and users can create models in a much lower level language, like we saw Jeremy doing, sort of much more drag and drop than hard coding in C++, which was like really difficult. So not only has data collection and analysis ramped up that, but the proliferation of connected devices, that's the Internet of Things, if you will, has even helped speed up the development of AI. So I'm just going to list some of the sectors that are on the start of their AI journey. Some of them are a little bit deeper into their AI journey, just because what they do is more related to machine learning. But they're all sort of in their development stages. So anything I mention here is certainly projects that need to be improved upon. And for you guys out there that are interested in some of the things that I'm talking about, take notes and think about how you can improve upon these industries. Regardless, the impact of artificial intelligence is hard to ignore. So yeah, let me just start with this list that I have here. So first one I have is transportation. Of course, we've seen self-driving cars being made huge leaps and bounds. Outside of the US, Tesla is probably the most notable one. We've seen some of their self-driving car videos. And in China, Baidu is actually doing great with self-driving cars, and has actually revitalized the company in a way that people are starting to believe in Baidu again. There's a lot of pressure on the tech companies now in China due to increased competition and more government oversight. You probably all have heard of the failed Ant Financial IPO, but Alibaba was not the only company to suffer from sort of that wave of technological oversight coming from Beijing. But the good news is that a lot of the tech companies have not shied away from continuing to build, and one of them has been Baidu, and they do believe that AI, self-driving cars and stuff is the way that their company is going to go in the future. I think we can see now that in many modern cities, subways, things on rails, things that are a little bit easier to drive, are already being powered by AI. And we will continue to see buses and even airplanes completely run by AI. Obviously, autopilot is not something that's new. You could kind of consider autopilot to be some sort of early form of AI. But as the AI improves, we will see sort of all planes be completely automated. So there's a lot of growth there. Manufacturing, especially in the big manufacturing plants, we're seeing a lot of AI-powered robots now working alongside humans to perform, at first limited tasks, just like stacking or organizing. But now we're seeing complete end-to-end robots in factories, especially in Shenzhen, where they're really pushing completely automated factories. There are factories now in Shenzhen that just have one human operating, sort of doing a quality control check during the whole end-to-end process. So the robot will do everything to make, let's say, a cell phone. It will get produced, and then there will just sort of be a human at the end just checking that. And that might not go away for a while, but the end-to-end solution of a robot creating a fully usable product sort of already exists, but it is not universal, certainly not universal across industries outside of technology. So we will see that have a lot of room to grow too. And certainly the analysis ability of robots, that is what needs to be strengthened the most. Robots are good at building things, but they're not good at analyzing whether they've built something of quality or not. So that is probably the most room to grow in that sector. Then we have healthcare. So comparatively, the AI field of healthcare, diseases are now more quickly and accurately diagnosed. Drug discovery is sped up and streamlined, and virtual nursing assistants monitoring patients using big data analysis actually to create a more personalized experience for patients than if a human were were to be taking care of the patient. Sort of, you can imagine that the human touch may be lost, but a robot will be able to analyze the data of a certain patient and be able to administer sort of a more accurate dose or medical amount based on previous data that a doctor might need time to analyze. And if it is a time-sensitive medical situation, then you would sort of want to count on the robot there. Just to refer back to Alibaba, we did a lot of work on the development of AI during the COVID times to not only locate bad areas that were very sensitive towards COVID, but be able to administer the right supplies to those places in time. And that was all due to AI and machine learning growth technology. In education, textbooks are now getting digitalized with the help of AI. So early stage virtual tutors assist human instructors, and facial analysis gauges the emotions of students to help determine who's struggling or bored, and to actually change the course material to keep the students more excited. I think that's something teachers certainly have had a hard time with, especially as classes get much larger. Imagine half the class is very interested, and the other half of the class is less interested. And it's hard to tailor the course material to make everyone sort of included and sort of maximum everyone's learning. But now with these sort of individual targeting at each student to be able to recognize sort of the emotional range of students, we can figure out what is the best way to teach each student. And certainly, it's certainly true. I mean, being a teacher once before, and of course being a student much of my life, being happy and being excited about learning is a very important part of the learning experience. And being bored and tired and uninterested is a really easy way to not learn anything. So not only is like the educational material getting tailored towards students, but the reaction of students and the understanding of students is also increasing. So that will help educators better tailor course material to their students. And that is more of a project on human emotions, childhood growth, understanding the way humans learn. That's going to take many, many years of not only coding, but understanding the educational development of students, which I don't think we've even mastered yet. But hopefully we can use what we learn from computers to better inform these emotional responses from students and actually learn more about the educational experience ourselves from using predictive models. So that's really exciting, just sort of all around the educational experience. And not only kids, of course, too. Like this is also very important for adults. You know, learning is a lifelong journey, and it's important to judge different emotional reactions from adults and students when they're learning to like most effectively teach them. Media, so journalism is now harnessing AI too, and will continue to benefit from it. Bloomberg uses cyborg technology to help make quick sense of complex financial reports, right? So, I mean, that's a little bit touching into the financial industry, but the Associated Press also employs the natural language abilities of automated insights to produce over 4,000 earning report stories every year, which is like 4 times more than the recent past. So sort of auto creating news articles is something that we can think about too. not only just being able to analyze numbers real quick to give like really nice detailed financial reports, but also be able to analyze groups of people, see what they're interested, the media that they're interested in, and being able to tailor media towards certain groups in a more effective way. And also being able to read feedback from those groups and say, okay, this media is not for me, or I think this media is too biased, or I think this media is fake. And then being able to put that feedback back into the predictive machine and say, okay, this group of people thinks that this sort of media is not very trustworthy. Therefore, our approach to giving media to these people, maybe can have much stronger feedback on what sort of thing is the most effective. Hello?
Welcome back, James.
Sorry. Everything okay?
Yeah, okay. Just
Okay, okay.
for a while.
Okay. I don't think I talked much past. So I was talking about media. I was kind of done talking about media. Just sort of being able to help both the readers and the creators of the media better get information to people. And the last one I'd like to talk about is customer service. I was recently reading that Google is working on an AI assistant that can place human-like calls to make appointments, to say your hair salon or your grocery store, or if you need to make an appointment, something like this. The AI can help you do that. So it's not just when you call the customer service center, you're talking to a robot. Obviously, that's going to improve a lot. Many of you probably have frustrating stories with that now, and so that's going to improve a lot, and that will be a lot better. But also giving the AI power to the consumers, so that they can use this technology to make appointments and make those calls that they would normally have to make to services that they want, and they can sort of let that be handled by an AI. When you have your custom made robot too for you, it can also understand more about who you are and the nuances of your speaking style and things like that, so that when you do use that to place calls, it's not sort of just a generic call center robot, but something that sounds more like the way you would talk. And so that's really exciting, because it sort of like automates a lot of boring service calls that we make all the time. And so having robots and that AI not just be a company used thing, but be able to give a working AI service, a machine learning service to a consumer to say, okay, now you can use this to fulfill A, B, and C task in your day, is going to make the consumer or the user sort of more distant away from doing boring things they don't want to do, like booking appointments or looking up flights or calling to see what happened to their lost bag. The list goes on and on. Okay, so I just have a few more minutes here. I just wanted to share with you guys the machine learning courses that we offer at the Alibaba Cloud Academy, just because you guys are really interested in this stuff. That's why you're here, and you've listened to it all the way to the end. So I'd like to just share with you what we offer here. Everyone can see this, courses to grow on. Okay. Oh, sorry. There. Oh, okay. Hopefully everyone can see this. These are the major courses that we have under machine learning. I'd really like to highlight the machine learning specialty. That is our most comprehensive course, and that really gives you the full, front to back about not only what machine learning is, but how to get going with Alibaba Cloud's PAI that you saw Jeremy sharing in the beginning of this video. So this career path teaches about end-to-end machine learning services, including data processing, engineering, model training, model prediction, model evaluation, and it combines all of these things to make like a comprehensive AI solution that is much easier for you to use than sort of hard coding things before. The Alibaba Cloud Machine Learning Platform PAI is super user-friendly, especially for developers. If you guys have had experience doing machine learning before, and you were seeing Jeremy's demo, you can see that it's there's some parts of it that are very, very drag and drop, and you can see the area, you can see all the arrows and stuff. So it's very easy to see where your algorithm is going and where you need to improve it and all that stuff. So everything that Jeremy was talking about in the beginning of the video would be covered in this machine learning specialty. It's 8 courses. Each course is about 40 minutes long. And then at the end, there's a larger machine learning test that if you pass, has a machine learning specialty certification that is yours. So you can take that around and say you're a machine learning expert. So I highly recommend that. Outside of that, there's sort of just a couple smaller courses. These are individual Clouder certification courses here on the bottom. One is just the very beginner course. This is sort of a math practical course about linear regression. Linear regressions is one of the main modeling tools that we use for machine learning algorithms. And that course is very nice for just teaching you how linear regression and machine learning are related. As you build your first machine learning models, linear regression will be very important to understanding how successful they are. And the second one is about heart disease prediction. So there's a big data set in there, and we look at how to predict heart disease in certain patients using a linear regression model. And then the third one is a little bit more complicated, using vector machine implementation, sort of the next level above linear regression, also all in PAI. So that is sort of a higher level course. But like I said, if you're interested in this stuff, highly recommend you try the specialty. It's a really great group of courses, and by the end you will feel comfortable building your own algorithm. Okay, do you cover AIoT? So artificial Internet of Things. Yeah, so within the machine learning specialty, we do talk about implementing algorithms into hardware. And while we don't talk about specific pieces of hardware that much, we do have, we do talk about how this code would sort of directly relate to implementing it into hardware. So while we don't talk about the hardware itself, we do talk about getting the code into the hardware. So if you're more interested in IoT, we have more specific courses on IoT in our Clouder list. And that can be found at edu.alibabacloud.com. Okay. I don't see any more questions here right now. So I think I will close the Ding Talk. Thank you guys for joining us today. A good hour of machine learning conversation. If you have any more questions, feel free to contact us at the Academy. We're happy to keep the conversation going. Jermaine, why don't I send it back to you?
Sure. Okay. Alrighty, thank you so much everyone for today. Do look out for our updates for the next session, which will be happening next month. Thank you and see you.
Bye, guys. Thanks for watching. Bye.